Okay, today we're going to look at section 7.6, polynomial division. So, with polynomial division, we're going to start with monomials and then we'll move over to polynomials. So with monomials, what we're going to do is we're going to rewrite the expression as separated fractions that then you can cancel items in each term, and then you'll have a sum of the fractions. And so we can see what I'm talking about is you're going to have this polynomial, which is a trinomial, divided by this monomial. And then we're going to rewrite it as basically three terms that are fractions. We'll have the following. We'll have, and it's going to become 20n to the fourth over 10n plus n to the third over 10n plus 40n squared over 10n. And now what we can do is we can cancel. So if we cancel here, say in a different color, we can say, well, one of those 10s goes into here and we're left with 2. One of these cancels one of these, we're left with 3. Now in this one, all we can cancel is one of those cancels one of those, we're left with 2. Here, 10 of those cancels, and then there's 4 left here. One of those cancels one of those, and that's what we end up with. And so now if we rewrite our trinomial, now we have 2n to the third plus, now we have n squared over 10 plus, now we have 4n. And that would be our final answer, and that would be the division of this polynomial by this monomial. Same thing would go here. So if we rewrite this, that would give us 10n to the fourth over 10n squared plus 50n to the third over 10n squared plus 2n squared over 10n squared. Now what we can do is we can cancel things again. Now this one, the two 10s cancel, we're just left with 1. 2 of these cancel 2 of these, so we have 2 left. 10 of those cancel there, and we have 5. Those 2 cancel 2 of those, we're left with 1. Well, that one goes in here once, and it goes in here 5 times, and those both cancel. So, rewriting the trinomial now, what we have is just n squared, then plus, now we have 5n, plus, now we just have 1 over 5. Okay. And so that's what we would get when we do the division with monomials into a polynomial. Now, when we do polynomial division with polynomials, though, it's going to be a little different. It's going to be kind of like long division. So if you remember long division, you have, one thing divided by another, and you have to kind of multiply, subtract, all that good stuff. That's going to work the same way here. Now, the key with polynomial divisions are if there are any missing terms as you're writing the polynomial in descending powers of the variable, you need to put placeholders. So if you're missing an x squared, there's no x squared, then you have to go and put 0x squared. So basically you use the coefficient 0 on whatever term is missing. So let's first look again to kind of remember how we did long division, and then we'll move on to actual division with polynomials. So this says take 5 into 705. Okay. So when we do this, 5 will go into 7 one time, and that's 5. Now we subtract 7 minus 5 is 2. Now we bring down the 0. 5 goes into 20 4 times, and that's going to be 20. We subtract, that's 0. Now we bring down the 5. 5 goes into there once, that's 5. Subtract, that's 0. And so our answer then is just going to be the 141. Okay. Now, the key things we need to remember are the 5 is called the divisor. This is called the dividend. This is the quotient. And if there's a number here, that is the remainder. Okay, so we'll have all those different things, and it's going to work the same way with polynomials. Now, with the remainder, remember, if there's, say there was a remainder of 2, you're going to put that up here, and it's going to be then like the 2 over the divisor. So you just have like, you'd have 141 and 2/5 if that was the case. Now, since we have 0, it's going to be 0 over 5, which is just 0. So we just have 141 is our actual value here. All right, so let's move on and start looking at how do we divide polynomials. Well, basically, like I said, it's an extension of the long division. So we're going to take our divisor into our dividend, and we just do the same things we've done before. So now we have n plus 5 out front, and then we have n squared plus 13n plus 32. And now what we do is we look at the first term here and whatever is the first term in the case of this here, the trinomial. And eventually it's going to get down to binomials as we subtract and add and stuff. But so how many times will n, or what do we have to multiply n by to get n squared? Well, what we multiply n by to get n squared is n. So now we take this n times this binomial. So n times n is going to give us n squared. N times 5n is going to be plus 5n. Now remember, we subtract, but since we have two things now, I'm going to put parentheses around it. So then I have to take n squared minus n squared is 0n squared, so we can just leave that out. 13 minus 5n, well, that's going to give us our 8n. And now we're at the point where we did before, we have to bring down the next piece. Well, the next piece is plus 32. So now, what do we have to multiply this n by to get 8n? Well, you have to multiply it by 8. So we're just going to plus 8. Now we take 8 times this, so that's going to give us 8n plus 40. And again, we're going to subtract, and we're going to subtract that whole thing. So take 8n minus 8n is 0n. 32 minus 40 is going to be minus 8. And this then is our remainder. So what we have is we have a minus 8, so we're going to say minus 8 over our divisor, which was n plus 5. And so that whole thing up there is going to be our quotient. So if we write it out as by itself, we have n plus 8 minus 8 over n plus 5. So that would be our answer for the trinomial divided by the binomial. All right, so let's do the next one here. Basically the same thing. It looks like we have all the things in decreasing power, so we're just going to take a minus 8 into a squared minus 4a minus 38. Now a times what will give us a squared? Well, times a. So now we take a times the binomial, so that gives us a squared minus 8a. Now we're going to subtract the whole thing, so we'll put the negative in there. So it's a squared minus a squared is 0. Now minus 4a plus 8a is going to give us a 4a. We bring down our minus 38. Now we're looking, again, just at the first thing. So a times what will give us 4a? Well, times 4. So now we take 4 times that, so that's going to give us 4a minus 32. Again, we're going to subtract the whole thing. So 4a minus 4a is 0, which is what we want. Now we have a minus 38 plus 32, so that's going to give us a minus 6. And so that's going to give us a minus 6 over our divisor of a minus 8. And so our answer is a plus 4 minus 6 over a minus 8. Okay. So far we haven't had to worry about adding any extra terms. And this one looks like we don't have to either, but now this time we don't have just a plain old x here, we have a 10x. So it's going to be a little bit different. So we're just going to say, well, that's 10x minus 2 goes into, now we have 10x squared minus 32x plus 9. Okay, well, 10x times what gives us 10x squared? Well, times x. And that gives us 10x squared, and then minus 2x. Again, we're going to subtract off the whole thing. So the first part cancels, then we have a minus 32 plus 2, so it's going to be a minus 30x. Now we're going to bring down plus 9. Well, 10x times what gives us a minus 30x? Well, times a minus 3. And that's going to give us minus 30x. And then minus 3 times minus 2 is going to be plus 6. Now we subtract that whole thing off, so when we add those, they cancel. 9 minus 6 is 3, and that's our remainder, so it's going to be plus 3 over 10x minus 2. So our final answer is x minus 3 plus 3 over 10x minus 2. Okay. Now the next one has the first point where we actually have to add in something. And if you think about this, this really is n squared plus 0x minus 4 over n minus 2. So we had to add in that placeholder of the x's, and that way when we do all our subtraction and stuff up here, we have that placeholder, so it's going to actually work out better. So if we take n minus 2 into n squared plus 0x minus 4. Now n times what is n squared? Well, times n. So that's going to give us n squared. And then we have minus, I guess I'm changing from n's to x's. So that should be an n, and that should be an n2. All right, so then that's minus 2n. So I subtract that off. When I do that, that's 0. And now we have 0 minus a minus 2, so that's going to be 2n. Bring down the minus 4. Now n times what's that? Well, times 2. So that's going to give me 2n minus 4. Subtract. So that's going to give us 0. That's going to give us 0. So our answer is just n plus 2. So sometimes you don't end up with a parenthesis or a remainder, sometimes you do. And again, it just depends on what your last value at that point there is. Okay. Let's do some more. Again, we need to look. So we go 3, 2, 1, 0. So that looks good. And then we just have that. So we can just rewrite this as our division. So that gives us a cubed plus 15a squared plus 49a minus 55. So a times what is a cubed? Well, a times a squared gives us a cubed. So that's going to be a cubed. And then 7 times a squared is going to be plus 7a squared. Now we're going to subtract that off, so those cancel. And then when we subtract that, 15 minus 7 is going to give us 8a squared. Bring down our plus 49a. So this a times what is a squared? Well, times 8a. So that's going to give us 8a squared. And then plus, and 7 times 8 is going to be 56a. And now we subtract that off. All right, so now we have 8a squared minus 8a squared is 0. Now 49 minus 56 is going to give us a minus 7a and minus 55. And now a times what gives us a minus 7a? Well, times a minus 7. And so that's going to give us a minus 7a. Then minus 49. And so now we subtract that off. Those subtract, that gives us 0. And 55 negative plus 49, that's going to give us a 6 rather, sorry. Get my eraser. So that's going to give us a minus 6. And so that's our remainder. So it's going to be a minus 6 over a plus 7. And so our total answer is going to be a squared plus 8a minus 7 minus 6 over a plus 7. And so that would be our answer for that division. All right, so the next one here, again, it looks like we have all our terms, n squared, n, no n, and so we can just take 4n plus 5 into 4n squared minus 23n minus 38. So 4n times what gives us 4n squared? Well, just times n. That will give us 4n squared plus 5n. So we're going to subtract that off. Now, when we subtract that off, we're going to have minus 23 minus 5, so that's a minus 28n, and then minus 38. So 4 times what gives us a negative 28n? Well, that's going to be 4 times a negative 7. 7. And so that's going to give us negative 28n and then minus 35. Again, we're going to subtract that off, so that's going to give us 0. And minus 38 plus 35 is going to give us a minus 3. And so we have a minus 3 over our 4n plus 5, our divisor. And so that says n, n minus 7 minus the 3 over our 4n plus 5. So that would be our answer, dividing that trinomial by that binomial. All right, a couple more and then we'll move to functions. All right, so we look here, we have a 3, a 2, a 1, a none, and just have x, so that looks good. So what we can do is we can take 2x plus 6 into 2x cubed plus 12x squared plus 4x minus 37. Now what do we take 2x times to get 2x cubed? Well, we take that times x squared. And so that's going to give us 2x cubed plus 6x squared. Now we're going to subtract that off. So 12 minus 6 is going to give us 6x squared plus our 4x when we bring that down. Now 2x times what gives us 6x squared? Well, times 3x. And so that gives us 6x squared plus 18x. Subtract that off. Now we have 4 minus 18, so that's a minus 14x. And then minus 37. All right, so now, oops, yeah, okay. So now what do we have? If we have 2 times what? Well, minus 7 will give us a minus 14x. And then 6 times 7 is a 42, so that's a minus 42. Subtract. That cancels, and we have minus 37 plus 42, so that looks to be a 5. And so it's going to be plus 5 over 2x plus 6. Okay. All right. So what do we have now? So that's what we have is x squared plus 3x minus 7 plus our 5 over 2x plus 6. All right. Last one, we have a 4, we're missing a 3, then we have a 2, a 1, and a 0. So this is really 4x to the 4th plus 0x cubed minus 3x squared plus 2x minus 5 all over our 2x minus 3. So 2x minus 3 into 4x to the 4th plus 0x to the 3rd minus 3x squared plus 2x minus 5. And now we can work this problem. So 2 times what will give us this? Well, 2 times 2, and we also need x cubed, so it'll be 2x cubed. So that will give us a 4x to the 4th. This will give us a minus 6x to the 3rd. So now we're going to subtract that off. Those become 0, 0, and that's going to become plus 6x cubed. So that's going to give us 6x cubed. Now we bring down our minus 3x squared. So 2 times what is 3? 2x times what is 6x cubed? Well, times 3x squared. That gives us 6x cubed. And then we have minus 9x squared. So that subtracts. Minus 3 plus 9, so it's going to give us 6x squared. Now we're going to bring down plus 2x. So 2x times what gives us 6x squared? So that's going to be a 3x. That's going to give us 6x squared. And then minus 9x. Subtract that. So 2 plus 9, that's going to give us 11x. And now we bring down our minus 5. Now, this one is not going to be so nice. What do we have to take 2 times to get 11? Well, this one we kind of have to think about. If we take 2 times 11 over 2, the 2's cancel, and we just get 11. So what we're going to have to do is take that times 11 over 2. Okay, so when we do that, that's going to give us 11x. And then here we have a minus 3 times that, so that's going to be minus 33 over 2. So now we subtract. Now let's put this here. The 5, we have to have a common denominator of 2. So that's going to give us really a minus 10 over 2. Then we have a minus 33, so plus 33 over 2. So 33 minus 10 is going to give us 23 over 2. So that's going to be plus 23 over 2 over our 2x minus 3. Okay, so a little more complicated. Now this one we can rewrite. Now let's say we have 2x cubed plus 3x squared plus 3x plus 11 halves plus. Now this, if we do a different way, we could actually see that's 23 over 2 times 2x minus 3. And we would leave this part here because we want to make sure we remember what our denominator was, our divisor. And so this would then be how we write it. You could also keep it as a 23 over 2 in the numerator. That works as well. But either one of those are going to be your final answer for that division. Okay. So polynomial division with functions. So really it's going to work exactly the same as what we've been doing. We're just going to have different notation along the way. So basically, if we're going to have two functions, f and g, and we want to divide them, say we want to take f divided by g of x, that means we're just going to take our function f of x divided by our function g of x, and when we get that division, that'll be our answer. Now here, x is the domain of f and g, and we can't have g of x equal 0. So g of x cannot equal 0. So that's a stipulation there. And so from now, we just are going to look at how they write these questions and then how do we solve them. So they write them in the following format. Let f of x equal this trinomial or this polynomial, 4 terms, and g of x equal this binomial, and they want us to take and divide them. So when we divide them, we're just going to take x plus 2 into x cubed minus 2x squared minus 4x minus 5. All the terms are there, so we didn't have to add anything. So now x times what gives us x cubed? Well, to x times x squared. So that's x cubed plus 2x squared. Now we subtract. That minus that is 0. Minus 2 is going to be minus 4x squared. Bring down a minus 4x. X times what gives us that? Well, that's a minus 4x. So it's going to be a minus 4x squared minus 8x. Again, we're subtract that whole thing off. That becomes 0. A minus 4 plus 8 is going to be 4x. Now we bring down our minus 5. So this is going to be plus 4. Now we're going to run out of room. And so that's going to be 4x. And that's going to be plus 8. Again, we're going to subtract that off. So minus 5 minus 8 is going to be a minus 13. So that's going to be a minus 13 over x plus 2. Okay. And so if we want to do like we've been doing, kind of, just write it off to the side, our answer then is x squared minus 4x plus 4 minus 13 over our divisor of x plus 2. Now, the same thing works here. Now, this time we're having k and f instead of f and g, and we have n instead of x, but it works exactly the same. We just have to plug in things appropriately. So let's say and take k divided by f. Well, this is our k. This is our f. Well, notice our k is missing a term, so we have to rewrite that as n squared plus 0n plus 5 all over 3n plus 5. So now, if we rewrite that into the division, we have this. Now, this is one of those that's going to be complicated again. What do we take 3n by to get n squared? Well, we know we have to take it times n, because the n times n will give us n squared. But 3 times what gives us 1? Well, 3 times 1/3 will give us 1, because 1/3 times 3 is 1. And so now we have to multiply by fractions. So now if we take 1/3 n times 3n, that's going to give us n squared. And 5 times that's going to be plus 5/3 n. So this one's not so nice. So that gives us 0, and when we do that, that's going to be a minus 5/3 n. Bring down our plus 5. All right, so now we have to think about what do we have to take this number by to get this? Well, if we're going to go and we want to get 5/3, and we have some 3 in here, let's say that's what we have. What do we have to do? Well, we have to multiply that by 1/3. So if we multiply that by 1/3, that gives us 5/9. So if we take 5/9 times our 3n, that should give us what we have here, because what we've done is basically went backwards. We started with what we have, 3n equals, and we need the 5/3. And so we multiply by the 1/3, multiply by 1/3, 5/9. And so now if we take and say, okay, well, we need a minus 5/9 because we need that negative. Well, 5/9 times 3, the 3 will go into 9 3 times, we have a minus 5/3 n. Now here, a minus 5/9 times a plus 5 is going to give us a minus 25/9. And we subtract that off. Those go to 0. And now we probably should multiply by 9/9, so we have the same denominator here. So that's going to be 45/9. This is going to be 25/9. And it's going to be a plus because it's a minus, so it's going to be plus. So now we just have to add those two together. So it's 70/9. And so that's our remainder. So then we have plus 70/9 over the 3n plus 5. Okay. Now again, if we rewrite that, that's going to give us 1/3 n minus 5/9. And then we can keep it as the 70/9 over the 3n plus 5, or we can say plus 70 over, and we can put our 9 in the denominator and keep the 3n plus 5. And then that would be another way to represent this. So we can keep the numerator like this, 70/9, or we can put it 70/9 and then put our divisor here in the bottom as well. All right, so that finishes section 7.6, and so hopefully that helped.